Tonight's video is on acids and bases. This is Cool Chemistry Show Activity 7. It's a review of what we've been talking about the last few days here. So this should be fairly familiar material and hopefully will help you prepare for your test on Friday. Now to begin with, acids are proton donors and they have a sour taste and they react with metals. They also have a pH between 0 and 7. Whereas bases have hydroxide ions, OH-. They have a bitter taste and they react with phenolphthalein. Their pH is found between 7 and 14. Now to give you an idea of phenolphthalein and what it does, phenolphthalein changes from clear to red depending on what the pH is. So at a low pH, or an acidic pH of 2, it's clear. As you get closer to pH of 9 and 10, it's going to change color and become more pink. It won't change until it gets to that color. It's an indicator just for bases. So you cannot use this to identify whether something is an acid. When we're talking about acids here, what we're talking about is hydrochloric acid as our example here in the presence of water, H2O. What happens is the hydrogen on the hydrochloric acid comes over to our water molecule to make it H3O+, and it leaves us with just a Cl- when it's all done. Now, what is pH? It's a measurement of the hydrogen concentration. Okay, so the more acidic something is, the higher the pH is. The more basic something is, the less protons it has, or hydrogen. So you can see how this relationship works out. At neutral pH, we have an equal number of hydrogen and hydroxide ions, and that's a pH of 7. And that's roughly equal to pure water and blood. Now, if we go into increasing acidity, what happens is the concentration of hydrogen increases, and so you get a lower pH, and this makes it more acidic. So tomato juice, lemon juice, stomach acid, hydrochloric acid, these all have low pHs. And you also see that as the hydrogen concentration increases, the hydroxide concentration decreases. Now, if you go the other way and you look at how basic something is, you're dealing with a decrease in the hydrogen concentration, and you're dealing with an increase in the hydroxide concentration. So it has a higher pH, and this is mainly your household cleaners, so and some medications, so like milk and magnesia for upset stomachs, household ammonia, washing soap, sodium hydroxide. These all have high pHs. Here's another picture of that, just so you can see the increase in the acidity or the increase in basicity, depending on the pH. So to my left we have increase in concentration of hydrogen, decrease in pH. To the right we have decrease in hydrogen concentration, decrease in pH. Now if you notice, the concentration, the exponents match up with what the pH is. So a concentration of 10 to the 0 is pH of 0. 10 to the negative 1 is pH of 1. 10 to the negative 2 is a pH of 2. So on and so on. The slide here again is just it's just more examples in the pHs that they're found at. So we've got battery acid at the extreme acidic side and drain cleaner at the extreme basic side. The last indicator solution that I want to talk about here today for pH is that of universal indicator here. And so, universal indicator, when it's a neutral pH, is green in color. And as it becomes more acidic, it goes from yellow to red. As it becomes more basic, it goes towards purple. This is a great way to tell the pH of either an acid or a base. I hope this video helps you review a little bit for our upcoming tests, and I will see you tomorrow.